You are loud and
Okay. Good evening, all. Uh, on behalf of 128-year-old Maharshi Karve Stri Shikshan Sanstha's Cummins College of Engineering for Women, I welcome Mr. Prasanth Karakavalasa for this 6-day online faculty development program. I'm very glad to, tell you, Prasanth sir, this is a fourth day of the faculty development program, and the program is sponsored by AICTE Training and Learning ATAL Academy. ATAL is the initiative of AICTE, and under which we are taking the program. So it is sponsored by AICTE, and also we are doing it in association with ASM International Pune chapter. And the topic for the this FDP we have chosen is a 21st century materials, advancements in the material science and technology. And since now, many professors from the NITs, they have joined the session. Some PhD scholar, they have joined the sessions, and they have talked on the other material types like functionally graded material, nanomaterial. Yesterday, we had a talk of Dr. Rishikesh Gade on the simulation of behavior of nanomaterials.
Mhm.
So likewise, there are the sessions are planned in these 6 days online faculty development program. And I'm also glad to inform you that uh, around 170 participants, they have registered for the program remotely, and many of them are from mechanical background, material background, and electronics, civil background as well, physics, chemistry background as well, and almost all of them are faculties at their place, faculty in engineering colleges and science colleges, and some are the PhD scholars as well. And since the day one, around 110, 120 participants are attending this the sessions. Uh, so I welcome Mr. Prasanth sir for this faculty development program, and let me take privilege to introduce Prasanth sir. Nikhil, please, next slide. Mr. Prasanth is currently leading a material science and engineering teams for Cummins Components and Software (CCS) in Pune, India. He has been working with Cummins for past 13 years in various business units, including new and recon parts, turbo technologies, and fuel systems. He has completed masters in metallurgical and materials engineering from IIT Madras, Chennai. He also worked closely with ASM International Pune and the Cummins Industry Academia collaboration teams. So, on behalf of Cummins, I welcome Prasanth sir. And without wasting any time, I hand over this platform to you. And I hope all the participants will enjoy the session. Thank you.
Thank you, Mr. Prasanna. Thanks for the very
Thanks.
brief introduction. So, if I may share my screen.
Yeah. Nikhil, you please stop it. Yeah, now you can do.
Okay, give me 1 second. Just fumbling with my. I hope my screen is visible.
Yes. Yes, visible, perfectly visible.
Okay, thank you for the confirmation. Okay, when I was looking at the photograph in my introduction, I kind of assumed you took it from my LinkedIn profile, and that reminded me I should get that updated. Clearly, there have been some changes since then. Good evening, everyone. I appreciate everyone taking time today to attend this session. I know we all have our full day jobs in the morning, and attending these sessions can be a little tiresome after we are done with everything. I'll try to keep the session entertaining, engaging. Um I'm going to give you a different perspective of material science and engineering, or technology, as we like to call it. I basically have worked in fuel systems for a very long time, so I'll try to provide, okay, outside of the regular domain of, metallurgical microscopes and scanning electron microscopies and laboratories, so, where all is material science engineering foraying into, and how me and my team are helping make a difference and supporting our business grow. The agenda, I kept it very brief, start off with a little introduction about Cummins. Then I'll give you an overview of material science engineering, how we are placed, what is our model operating structure, and what are our core competencies and advancements that we have done, which help us deliver our day-to-day job and more. And I'm hoping we would have plenty of time for questions towards the end. And yeah. In addition to what Prasanna has already said, I added a few pointers, one-page introduction about myself. As mentioned, I lead the Material Science and Engineering Group for Cummins Components and Software. That is my day job. I have two other hats that I wear. I'm also the Advanced Materials and what we call it as product preceding technology. This is before we have any product and we want to verify a technology. You call it PPT for short. I take care of that for Cummins Components and Software. I also lead the India Material Science Technical Functional Excellence. Basically, what functional excellence does is kind of gets all the material science engineers working in Cummins, India, and kind of create a platform for them to get together, share ideas, benchmark certain standards and specifications, and also create a bridge between the material science engineering teams that are working globally across Cummins and the ones that are working in India. The education, I have done my master's from IIT Chennai in metallurgical and materials engineering. My areas of expertise include heat treatment, failure analysis, coatings and platings, technical cleanliness, product design, and simulation. Uh, so I basically started off in Cummins itself in new and recon parts in 2011. Then I moved to Turbo Technologies as a design engineer, worked there for 2 years, and finally in 2016 actually came back to my core subject, which is material science in Cummins Fuel Systems. Thereafter, there have been some changes in the business units. Electronics became a part of fuel systems in 2019. Then kind of took on the functional excellence leader role in 21, and currently I'm also leading a bigger team under the Cummins Components and Software. Okay, a brief introduction about Cummins. Many of you might already be aware, so I would not spend too long on this. So Cummins was founded in 1919 by Classic Cummins and W.G. Ivan. So they believe that diesel power is something which can kind of power the world for a very long time, and which is true. This was more than 100 years ago, and we still have diesel engines powering many vehicles across the world. So we took of course, Cummins did not invent diesel technology. There was an available technology and we transformed it into a reliable everyday power source. Uh, the Cummins operates out of 190 countries and territories. They're globally about nearly 75,000 employees. There's, like I said, 105 years of industry leadership. We have dealership outreach to all our customers through 19,000 dealers, and we spend nearly $1.5 billion on an average in a year for R&D. Where Cummins is, like I said, located all around the world. So we have five major business units of Cummins. So the Indian business unit is located in US, India, Brazil, and UK. Components is again located in all these countries that you see. One common denominator you see is India is present in almost all the four core businesses in addition to US. India, in fact, China is missing out on the engine business, but they have the Accelera by Cummins. Accelera is a new division by Cummins, which focuses entirely on fossil-free, fuel-free power, either battery or electrified power. So these are the new technologies and innovations that Cummins is currently working on. Electrified powertrains. I was mentioning fuel cells, which is again hydrogen powered. Other hydrogen production technologies. You cannot run a fuel cell or a hydrogen internal combustion engine without having a reliable source of hydrogen. We are also working on automated manual transmissions or AMTs that are very popular in passenger vehicles now, passenger cars, sorry. We are also evaluating some 3D printing and additive manufacturing, a big footprint for material science here. Vehicle connectivity, we talk about big data and many of our cars today, right? You can connect them, you can remotely control them through an app, turn them off, turn on the AC from wherever you are. So all those things trying to integrate into the engine. The big data, right? Now you have so much connectivity and obviously that's going to generate a lot of data. So how do in the back end the computers mulch these numbers? How do we give predictive maintenance rather than preventive maintenance to our customers? And last but not the least, the buzzword of this generation, artificial intelligence. As I was mentioning, there are five operating segments in Cummins. The base engine or the base business where the core of the Cummins revenue comes from is called the engine business. That includes everything like the power cylinder, the crankshaft, cylinder heads, and other accessories. The power systems is an extension of the engine business in a way. They take care of all the high horsepower engines and where we have standby generator sets where that has to provide power in standby applications or on off highway applications. Then we have the components business. So all the peripheral systems that go onto the engine, like a after treatment system or a turbocharger, they go under the components business. That's a separate business operating unit. And distribution business ensures that all these three business units, whatever products they make, they go to our customers and customers get our after sales support through the DBUs. Um, then Accelera by Cummins, as I was mentioning, is a new business unit for all the fossil fuel free power generations that Cummins is working into. As I said, if I break down the components business unit, we have three major business units. We have the after treatments that is named Cummins Emission Solutions. We have the Cummins software and components and software where I currently am working out of. So this has the turbo technologies business. We have the engine braking. We have the Cummins fuel systems, and we also have the sensors and electronic module business. So these four together make up the Cummins components and software. Then the another mm, organization in the Cummins business unit is the drivetrain and the braking systems. This is where the automated manual transmissions and the transmission power lines for the Cummins engines coming from. We have a vast number of applications that Cummins engines are used in today. The heavy duty truck, the medium duty truck that we see on the roads. Pickup truck is something where it's very popular in the Europe and the US market. India, it's still catching up. Um, Bus, yes, we're present. Oil and gas, electrolysis, marine, defense and agriculture and rail. These are basically probably in terms of connectivity. These are the ones that Cummins is a heavy player in power generation, both standby and prime, that we like to call it. Cummins is also supporting those. Destination Zero is basically a Cummins vote to the community and to themselves that we want to lower our emissions today. We want to advance low carbon technologies, drive wide scale customer adoption, and main focus is to reduce the well to wheel emissions of our products. How we are going to achieve it is we'll continue to innovate and invest, but this is something that we are partnering with our suppliers and our customers to ensure that they understand that the actions are required today through crucial partnership, and Cummins will support through all the technology leadership that we have available. We are looking at different energy sources like low carbon fuels, decarbonized grid, green hydrogen economy, and how we are going to do the hydrogen storage. There are also other power solutions like can we make advanced engines with better fuel efficiency, lower impact to the environment. Can we come up with some kind of hybrid engine model which works? I think we are familiar with this. It works on fossil fuel as well as battery technology. Cummins also has a battery electric truck that we have launched, and fossil fuel, so fuel cell electric. So these are the different power solutions that Cummins is exploring as part of the Destination Zero initiative that we have taken. A quick look at Cummins in India. Again, a quick recap that, hey, this is how we are located. So within Pune, Cummins has the headquarters that we call it as India Office Campus, which is located in an area called Balewadi for those who are familiar with Pune. I myself work out of the India Technical Center, which is located a little on the northwestern side of Pune, I would say. So all the engineering and technical folks work out of the India Technical Center, or ITC, or that we like to call, and all the non-technical administration and purchasing, supply chain folks work out of the India office campus. Okay, now we move to a section where I talk about the Cummins. Yeah, sorry, let me get some water. And material science and engineering. So we always like to joke that, hey, ours is a secret society because we are always in the background doing applied alchemy and experimental blacksmithy. If you look at material science or metallurgy, we actually started off like this, right? A bunch of folks, forging, doing some blacksmithy work to make probably horseshoes, and an alchemist trying to mix different chemicals and potions and trying to make some medicine, hopefully. So we use our tagline, you can't really make it without materials. Of course, everything else is immaterial. If you look at the presence of our team, we are located at the every country or major operating country that Cummins operates in the world. So the headquarters, rather, I wouldn't say headquarters. The Cummins headquarters is located in Columbus, India now, and that's where we have the fuel systems engineering, the lab, the turbos engineering, and the turbos lab. Uh, we also have Valtrain, which is located in Bloomfield, Connecticut. We have some turbos lab in Charleston. At Juarez, we have our engineering. We also have a very big manufacturing hub in Juarez. Huddersfield in UK, that's the major headquarters for our turbo business, where we have both engineering lab and the production. Sudate in Sweden is again a fuel systems lab. Pune, where I'm located currently, we have all three turbos, fuel systems, a bit of valve train, and corporate R&D lab. Um, Fulton, which is a couple of hours from Pune, is we have another lab there that is co-located with the manufacturing facility. In China, we have two locations. One is in Wuhan, which is clearly famous now after 2019, 2020. We have our headquarters for fuel systems where our engineering team operates out of in the lab. And in Wuxi, we have a turbos engineering team. We don't really have a lab there. So we always like to say that the sun never sets in the material science engineering group of CCS because all of us at any given time, someone will be available to assist and support. Okay, so if you look at the material science and engineering as a discipline, loosely put, it talks about development and application of microstructures and processes to meet a given application demand. Right. So we look at what is the performance need, and we have a microstructure at the other end of the spectrum. So to achieve this microstructure, what is the process we need to follow? And what properties would that process give in addition to microstructure? And will that properties suffice to the performance that we require? So that's exactly what a summary of material science engineering team groups can be. At the end of the day, we have to make sure our products meet our customers' performance expectations. So in order to achieve that, we have a range of technical subjects that we work on, including additive manufacturing, castings, weldings, coatings, polymers, powder metallurgy, there's heat treatments. We also work on lubricants and oils that go in our engine. We do a lot of non-destructive testing. We also work with the plant supply chain management teams to ensure that they are preventing rust formation on our parts while the parts are in transit. So, in a way, if you look at material science engineering, we collaborate with nearly every team in the supply chain. Starting with product engineering, either it could be the supply chain team, even the suppliers who directly and indirectly work with Cummins through our purchasing and supplier quality teams. We also, since we have our labs that are co-located with manufacturing hubs, we work very closely with the operations and the manufacturing teams to support their day-to-day production. We also work with the quality teams. Now, why this called quality engineering is we also have supplier quality improvement engineers. So they form under, they kind of fall under the quality engineering group and also the plant and product quality groups. So we also work with them. The remanufacturing division of Cummins is called Recon. So we also work with them to understand if they have any field failures and the customers want those to be remanufactured instead of, say, scrapping and buying something new. We work with the Recon or the Reman team to come up with processes which can help reclaim those failed parts, because we were part of the initial design, the material and process specifications of the product. So we end up being the best judges of what and how they can repair or reclaim these parts. If you look at an MSc role, I'm going to use the abbreviation MSc a lot. It basically stands for Material Science and Engineering. So if you look at a product life cycle, we kind of provide kind of conceptually and experience-based expert knowledge through testing and analytical capabilities so that the product engineers and the development teams can uh, incorporate those into the design of the product and help them solve rapid problems. So if you look at it, the cradle, this is the infant stage, right, of any product that when the product just started. So you have a new material or processing that's being developed, which is driven through what I explained, right? PPT, product preceding technology. And then if it's not just enough, if you have a new material and processing, you should also have a way to manufacture it. So we have something called advanced manufacturing or advanced method development, abbreviated AMD. While we are doing that, we also ensure that the products and the materials that we are choosing are environmentally sustainable, that they are complying with all the regulatory requirements. Cummins operates in every known country, so it's not just REACH and ROHS or USPA, EPA regulations, but the individual countries might have some requirements. So we have to ensure that we are complying with all these regulatory compliances. And then we move on to the VPIs or the new product introduction NPDs. That's more common methodology where whatever new material and process we have chosen and experimented with, we kind of give the validation and the selection for the material and process. During that time, if we have any failures, we call it FERG. So we either do the failure analysis and provide the counter specifications, countermeasures to address those failures. Once we kind of finish the validation step, we go to the material process specification. During the process, if there are any failures, we use the Six Sigma methodology to understand where the problem has come. This is most probably at the supplier end, but this could also be in-house within a Cummins facility. Then once the product is launched, we move into a plant support scenario where we audit products to a specification to ensure that plant is manufacturing parts that are meeting a preset specification or that the suppliers are sending parts which are meeting our specifications. During at the same time, we'll be getting feedbacks from suppliers and the field service teams on non-conforming materials. What is the fitness for service? Maybe during our validation, did we miss a certain failure mode, which we are trying to capture now during the service evaluation stage. Um, when your product is just into the market. At the same time, we also support the supplier quality engineers or suppliers for their development and PPAPs. We also help them, once the product matures, you would have a capacity increase. There will be some ask for reduction costs. So these are all continuous processes. SCAR is again a company Cummins term for supplier corrective action. If like we get non-conforming parts, due to some error in a supplier's process, how are we going to make changes to that process to ensure the parts are again reverting and being supplied to the specification? Once the product is launched, the FERG that I talked here becomes what we call a PQC. So there is a product quality committee which takes care of all the post-launch product failure. So we again support for the failure analysis and provide any corrective actions and improvement plans. Either in the design or the process, as the need may be. Towards the end, as the product is matured, we look into remanufacturing. We work with the recon teams, as I mentioned, to look at the remanufacturing report. And finally, we reach the end of the life of the product. So if you see the kind of the life cycle or the involvement of material science engineering is there throughout the process. It is not just, oh, okay, we selected a material, we are done with our job, or we selected a process, we kind of validated a supplier job. We are there right from the infant stage of the product to the end. Yeah, this is just what I explained in the earlier slide, but in a different format, graphical. So I like this graph because this kind of tells us on an average how a product life cycle looks like. So in the red line is the profits for the company. Let's be honest, at the end of the day, we are a business, and more sales means more profits, right? So um, of course, initially the profits will be low because we are investing for a new product, validation costs, developments. So after the initial introduction is when the profits will kind of start showing up. During After the product development, before introduction, you may have some sales because suppliers might be customers might be buying pre-alphas or proto samples for their validations at their end. So you would have some sales, and probably around somewhere here sales will mature. That's your peak maturity. So, and then once your sales start declining, that's when your product is reaching its end of life cycle. So yeah, one aspect that I probably missed in the previous slide is we also do support the company for competitive analysis and benchmarking any of other products. And like I said, we also help with the material process selection and specifications, supplier selections for special process such as heat treatment or any coatings that we do. So we help work with the purchasing team to do a supplier selection. During the initial development, if we have any failure analysis and improvement actions that are to be given, we provide those to the team. Um, yeah, I don't want to spend too much time here because I covered this in detail in the previous slide. So once the product is launched, I think this is where we continue to provide the product support. This could be to a supplier, this could be some warranty failure, this could be some cost reduction and continuous improvement. Once the product is launched, once you see that the sales are going up, your volumes are increasing, there's always a scope to reduce cost. If your product is over-engineered, that also opens up a lot of avenue for reducing the cost further. What's important is in the previous slide, I showed PPT as something that is we do at the infant stage, but this slide summarizes it more accurately. We do advanced PPT projects throughout the product life cycle. At any point, even for cost reduction or warranty, we might think, oh, this technology or this manufacturing process or this material is better than what we have today, but we do not have enough data to support this. So a PPT project may be launched at any stage, and somebody might take it upon themselves to prove that a particular technology, process, or material will be suitable replacement while the product is, in the field. Okay. Well, I'm doing better than my time. So, in terms of competencies, if you see, like I said, we have three different business units that fall under the Cummins components and software, material science, engineering. When I look at turbos, they mostly deal with superalloys or high temperature materials. Their main concerns or failure modes are either creep or thermal fatigue. Fuel systems on the other end of the spectrum, we deal with clean steels, heat treatments. Our main concern or a failure mechanism is pressure fatigue because our pumps operate at very high pressures, and we have uh, we have possibility that, well, a lot of possibility, certainty that the parts will be subjected to fluctuating pressures of fluid that are circulating within our pumps and injectors. You also work a lot with when I say poly, I think polyesters or elastomers sealants, because of the high pressure system, leaks are very common. So we have to use sealing more often than not. We have something called precision cleanliness or technical particle cleanliness. And of course, being fuel systems, we deal with different kinds of fuels, but our customers put into our engines and thereby into our fuel systems. Uh, I don't know, some of you might be aware, like we are in BS6 fuel era in India, but there are countries which still have BS4 fuel. And, we pretty much have to ensure that while we are validating the new high pressure systems for the new fuel, we also have to ensure it's backward compatible with the old fuel. Valve train, they have a very simple classic fatigue. That is their main area of concern or a problem, failure mode that they'll be worried about. But otherwise, if you look at the materials, they work with, commercial quality steels and some level of heat treatments. So, and this is where my team kind of has a synergy in terms of what are the common competencies that um, we can work together with. One is a casting technology, how a casting's made, and this applies both to ferrous and non-ferrous parts. Um, this could include the casting process itself, various casting processes that are available in the market, the alloys that go into casting, what kind of flowability, because as the emission norms and the requirements become stringent, our customers ask also become more demanding. So we need to critically look at how our castings are performing with the with the increasing and demanding applications that our customers are putting forth. We also have overlap with the coatings and tribology. As many of us know, coatings help improve the wear characteristics by reducing friction or just giving you a superficial surface hardness that can improve the overall wear resistance of the part. So that is also common between all three business units, operating segments. Corrosion, I don't think there's any industry, at least in the automotive, where corrosion is not a problem. So all three of operating units, corrosion becomes a big problem. How to prevent corrosion, how to um, assess the risk of a corrosion. And as you saw in one of the slides, the Cummins engine goes in different applications. We have certain applications which go in marine, which is a very acidic environment because of the salinity in the ocean or the sea where these engines are operating on. So corrosion becomes a um, big darn deal for many of us who are working on few of the programs which deal with that. Uh, Now, the new up and coming, we have been talking about hydrogen powered engines. So, not all the materials are compatible with hydrogen. Hydrogen embrittlement is a known problem that plagues many of the common materials that we work with. So, all three of these business units, we tend to whenever we have an application or a ask from our customer in terms of compatibility with hydrogen, we kind of have a common point that we all talk about. Again, this is very common. Laboratories, since if you remember the world map that I showed where we are located, there are certain locations where turbochargers has a lab, but fuel systems and valve train don't, and vice versa. So we ensure that all our labs are equally capable to inspect each of these products. So if, for example, if the requirements of a turbocharger product could be different from a fuel systems product, requiring a different equipment and a different expertise, but we cross-train and ensure that all the equipment that are necessary to support the turbocharger business is also available in fuel systems lab. And they do, and the vice versa is also true. Supplier management. Now, as these businesses migrated, we saw that there are certain suppliers who could be common, right? The kind of controls we need, the kind of quality systems that we need to ensure that the suppliers are giving products that adhere to our quality requirements. So the systems are common. So this is another point where we have a common synergy amongst all these business units, trying to when we try to converge and work as a team. So that kind of ends my second section where I wanted to talk about what are the overview of the Cummins components and software material science engineering. Where do we see overlaps? Where do we see our competencies go? In the next few slides, I'm going to dwell a little more into our core competencies with respect to steel coating, where we see our core strengths play out, and how we have changed the way we operate, and what are the advances that we did within our team to ensure that we meet, like I said, the ever-growing demand for smaller engines. That means smaller fuel systems, but you have higher operating pressures. Okay, the first one is steel quality and sourcing. This is one of our core competencies that we develop. Why is it critical? Is as we all know, the quality of the material or the steel that we use is very critical to ensure that we get robust strength and fatigue resistance even under the extreme cyclic pressure. The pressures that we are talking about is nearly in the order of 2100 to 2400 bar. So that's extremely high pressure. Uh, we have a team which has very in-depth knowledge of the steel making practices, where we work together to identify world-class steel mills that can provide the clean steel that fuel system business needs. We also have CES, which is Cummins Engineering Specifications, that suit for few applications, which is in line with the available industry or few of the other non-business, non-fuel systems business unit standards, but sometimes they may not suit the fuel system requirements. So we also want to protect our customers from adverse or poor quality steel allocations, especially during cyclic economy. Um, Especially for those of you who work closely in this industry, uh, during right after COVID, because oxygen was being redirected to the medical field, steel industries have a lead time of more than a year for supplying any special quality steel that you need. And that cyclic economy keeps happening. So we as Cummins, we kind of ensure that we look at the global supply chain of steel, what our requirement is, how our demand is looking like, and we redirect our suppliers and even our supply chain teams to proactively procure some of the grades which we think are going to become more difficult to source in the future, or we see that okay, there's an ever increasing demand for a particular grade. So how do we do that? We kind of have specifications for what we call it as critical steel or fuel system quality steel. We go through a steel mill valid or steel maker validation process, and approve the steel mills for each and every grade and bar diameters that we procure. We also have a comprehensive micro-inclusion rating method, which goes beyond the ASTM or DIN standard that we normally follow in the industry. So ensuring that, as I said, pressure. So we have requirements of fatigue strength control, and we kind of back uh, back calculate those into the inclusion rating that we give for our steels. We also have technological partnerships with many steel mills to ensure that we co-develop some of the grades which are unique either to Cummins or some of the applications that we take it for fuel systems. We also have a steel council. Now, this is comprised of material science engineering, product engineering, supply chain, even the supply chain continuity teams to ensure that we are offering solutions to the management on material quality issues. And like I said, we are also continuously monitoring steel market for what are the new opportunities or technological challenges that are coming up. Uh, for all the steel mills that we work with, we maintain a scorecard and we go on routine audits so that we can maintain a visibility of what is the supply base weakness or strength. These audits are done annually at least, similar to the AICTE that we do for heat treat shops. But this helps us keep a healthy check list on where the steel market is moving and if we should be worried or we can be relaxed about how it's going to impact the fuel system steel supply chain. In terms of applications, uh, yeah, I mean, we apply these competencies right from the design phase, starting with material quality and source selection. This is the steel maker source. So we call it as a directed by. So material science engineering tells the purchasing and the supplier where they should procure a particular grade of steel from. We also, like I said, through technology partnerships, we develop steel suppliers. They may have certain practices that they follow, but if our team feels that there could be improvements to ensure that the product quality is improved, we work with them very closely to make those improvements. We also have classifications in our steel that we specify on our products into high, low risk, depending on the criticality of the application, the availability of the steel in the commercial market, and of course, the cost and the lead time for these steels. So that when we have a design approval that we are going through, we are fully aware of, hey, what is the risk level of risk that we are taking by choosing a particular steel grade and a mill for a particular application. Obviously, we would love to be in the low risk product. Um, we love to be in the low risk area, but sometimes we have applications where the risk could go either to medium or high. And we again circle back and work with the Steel Council to see how that risk can be reduced. You can see some of the we had an oxide inclusion in our valve spring steel, which led to a failure, and there was a big issue of field failures that it caused. So the Steel Council kind of helps work with the steel mill in that case to suggest improvements and even work with the steel mill to install or establish some level of detection techniques to ensure this level of inclusions or something which is detrimental to the product are not present. Another core competency that we have is precision heat treatment. Fuel systems has a wide range of heat treatments. We heavily focus on vacuum-based processing because we tend to avoid intergranular oxidation or decarb on the surface, which are usually seen in SQF or an atmosphere-based process. We also have of course, we are all for all the metallurgists. We know that some of these requirements often conflict with each other. If you need a high hardness, then you are losing out on toughness. If you have a strong fatigue strength, then maybe distortion during the heat treatment could become a little problematic. And cleanliness of the parts itself, any of you who visited heat treat shop, that's not the cleanest place. You know, and then in fuel systems, we have a very stringent cleanliness requirement. I have a slide coming up where we talk about the technical cleanliness requirements. And fuel systems outsources most of our heat treatments to tier two suppliers. So sometimes suppliers may not have the required resources or understand our product like we do to gauge what is the criticality of a certain heat treatment. So how do we drive this heat treatment management? We have another council, believe it or not, it's called Heat Treatment Council, much like the Steel Council. So it's again it has supplier quality teams, it has purchasing team, it has product engineering, it has material science, and we focus our heat treat shops and the heat treat process itself based on what are the criticality of the part and the criticality of the heat treatment. We prioritize any change requests for heat treat shops. We even validate heat treat shop changes at our end based on the classification that we do. And we have supplier scorecards. We have something we call, everyone is aware of AIGCQI9, very common, but Cummins has its own, I would say, something which goes one step ahead of the CQI9 process. So we call it the Beyond CQI9, which focuses on the process control and the quality action plans. Again, this is driven, it's a co-driven initiative by the supplier quality team and the material science engineering team. And we also have a roadmap. We have a very detailed supplier validation plan for each and every heat treatment process. So we ensure that all these are driven through the heat treatment council. And then, like I said, there are different heat treatments that we generally delve into, either vacuum hardening or iron nitriding. Another core competency that we use and we have is the PVD or PECVD, that's plasma enhanced chemical vapor deposition, something like a DLC coating, right? So why is it important? So coatings are important for minimizing the wear and also improve in some cases, the chemical corrosion resistant. So we typically use coatings, especially where there are poor lubrication conditions, where we are seeing repeated sliding or reciprocating wear, which is very common in fuel systems application. And we also have to deal with different kinds of fuels. And then we might have conditions where, like I said, marine applications, right? You will have either a hydrophobic or a oleophobic condition where the oil may not adhere to a part because of that. So you cannot really give wear resistance through just lubricating oil. Uh, Also, we have seen cases where the coatings, when you reduce wear, you increase your fuel economy because you're reducing the parasitic friction losses. Um, we also ensure that the need for oil additives can be reduced due to additional lubrication. I would go one step ahead and say, hey, we can also provide longer oil drain intervals for our customers. That is because the oil gets dirty slower because you have less wear happening on your parts. And many suppliers, if you are again familiar with coating processes, many of the coating process suppliers have their own proprietary recipes. So our team has to ensure that we have good knowledge of the process so that we can make an informed decision. So how do we achieve it? We ensure that we are integrating the coatings and the coating properties right from the design stage. It's not something we do it. We design a product, we see it's failing, and then okay, let's add a plating. We do not go that way. We ensure that we understand the product application. We add coatings or platings as required, right in the initial phases of the design. We also audit the coating suppliers. We have a coating council, which is again a cross-functional group and globally works to ensure we are sharing the best practices and validation guidelines. And we have similar to the steel and the heat treatment, we have supplier scorecards for each and every supplier that we work with. Internally, we also work with the manufacturing process within the plant to ensure that the surface and the part preparation before the coating is meeting the required specification so that you get a sound coating from as an outcome. We work with many industry leading coating suppliers right from the concept phase, both in DLC coating and zinc platings and all these other coatings that we work to ensure that any advancements for providing a more robust coating solution can be implemented in the product. Below is a few applications. Like I said, we have match fit plungers that move within a barrel plunger where we need a low coefficient of friction and scuffing resistance and low oil to fuel transfer. Sometimes we may have a tappet with a bearing, so which has high loads and it can have, high frictional losses if it's not coated properly. The rightmost picture shows a broken pump injector because of poor adhesion coating. The coating kind of spalled off. That led to the plunger seizing and overall the injector failed. As I mentioned, failure analysis is another core competency that we kind of developed within the team. We have three primary failure modes that we are concerned with. One is a pressure fatigue. That's because, like I said, we are operating at more than 1800 bar pressures. So, and this is a cyclic loading. So that's why we call it pressure fatigue, much similar to the mechanical fatigue that we see where you have the load going up and down. Here, it's only thing difference is it's the hydrostatic fuel or oil pressure that goes up and down. This is required to ensure that we have a good fuel spray and we meet the required performance and the emission requirements of our customers. And when you have moving parts, wear is always a problem. We have another failure mode. We like to call it as beaten. Beaten is nothing but a combination of an impact loading plus sliding, because when you beat and then the surface slides, so you have a beaten process. You can have a pure polishing because of sliding, fretting, which is a relatively small, which is a small relative motion, then galling and erosion. Another big failure mode that we are often worried about is corrosion. All our fuel system parts are subjected to external conditions, even manufacturing fluids, right? Once we make a fuel systems, we give it to our engine customer, they put it on our engine. Before they put it, it might be subjected to some improper handling or storage. Some of the fuels that our customers purchase, not intentionally, but it could have higher water in fuel content, it could have higher sulfur content. So all these could initiate or accelerate the corrosion in our fuel system parts. So we have a very elaborate training plan for all our engineers and technicians. We use the ASM and ASM resources, Six Sigma tools, and hands-on coaching and mentoring. We have established practices and procedures for conducting failure analysis for each and every part. One of the Six Sigma methodology is a fault tree analysis. So either through a process of elimination or a fault tree analysis, we kind of help determine the potential causes so that the team works on the right improvement actions. Sometimes if we try and recreate the failure modes through some internal testing, either in fuel systems or at our supplier end. We also encourage our engineers to visit the scene of the crime, as we like to call it, to ensure we're getting all the facts right. Somebody might just say, "Oh, the fuel pump is broken," right? But if you go and see, you might see, "Oh, there was impact mark on the side of the engine or in the radiator hub," and that is the fuel pump breaking is actually a byproduct happen. We also work very closely with other business unit to understand the system level interactions. Like I said, fuel systems is just one part of an engine. Is there any other? Is the after treatment systems working fine? Was the air filter bypassed? So we work very closely with other business units to understand that. And like I mentioned before, we create what we call it as functional excellence practice or FEP and failure guide for each and every component that we analyze. Yeah, as I was telling, technical cleanliness, this is a differentiating competency. When you talk about material science engineering anywhere in the industry, they probably do not talk about precision cleaning, inspection, or assembly. So debris as small as very few microns can cause blockages in the fuel system, like the one that you see. This hole is hardly 130 to 150 microns apart, and we have such a small debris, which is basically a nylon thread that kind of tore off from somebody's shirt sleeve, and it went and blocked the fuel system, right? Mostly the debris are exogenous. That means these are coming from either the fuels or test fluids or the filtration system or simple handling. There could also be endogenous debris, right? During assembly, somebody chipped off something and that fell into the bore, blocking it. It also could be application wear. This happens very rarely, one in 10 million kind of case, but that's still a possibility that we are wary about. Of course, our customers ask is to we need to have a robust system against a wide range of applications. So, how do we achieve this precision cleaning? We have a Cummins engineering specifications or CES that we like to call for different cleanliness inspections. We have extensive training and enforcement of precision cleaning within the plant. It's not just material science engineering, but all our operations, technicians, the supply chain folks who handle the parts from one line to another assembly line, even our pallets, our washing systems, these are all audited continuously by our team. And we kind of give familiarization trainings, we give trainings so that they are aware of, hey, a technician might just step out of the assembly room and they come back and they forget to change their hand gloves or they forget to kind of go through the air curtain blower thing, and they are carrying contamination inside the assembly room. So we kind of give all those uh, uh, familiarizations, and we try to sensitize the team about the importance of cleanliness. We have ISO class 8 clean rooms nearly all the assembly plants that we have. So if you see the clean room here, it looks like you have lab coats, you have hair nets, you have nose mask. In fact, in some of the assembly lines, we even make nose masks and stuff so that if somebody has a beard, you don't have the hair falling into the assembly line. And we also have what we call it an AIB. That's basically the engine bulletin for our customers and end users on how to handle the fuel systems. For example, there's an engine which came to a dealer for upfitment. They might just open a fuel system and keep it on a dirty table instead of keeping it in a clean enclosure. So, and when they assemble this fuel system back, the dirt from the table can get picked up and it can enter the system and eventually it will block the system. Another differentiating competency that me and my team work on is special engineering processes. We have a lot of cross drilling, like the one that you see here, that can lead to burr generation. Now, loose burr can, like I said in the previous slide, it can always separate off and go and block some hole. So we use a variety of special process like thermal deburring or thermoelectric method, TEM, AFM, CDM. So we work with industries and university consortiums so that we understand this process better. How can we control the process parameters of this processes so that we get an output which we can predict, a predictable output. So we are developing some analytical modeling capabilities on how to integrate this into our design. And we have some in-house manufacturing capability, like this is the TEM at our Columbus plant. So we do some trials just to see how different um, uh, process parameters impact the output that we are getting. Uh, yeah, like I said, we are working with actuator materials, the electromechanical actuators, because as we move towards more stringent emission norms, the fuel injection becomes more and more crucial to control within milliseconds of the demand on-time demand that we call. So for that, we are looking at different metering valves, piezo injectors, piezoelectric assemblies. We are also effectively evaluating the performance transparencies in fueling using electromagnetic actuators. Uh, One of the big advantage of using the electromagnetic actuators is also making our fuel systems compact. So as I said, the engines are becoming smaller and smaller as technology is advancing. So in extension, we should also make sure that our fuel systems become small. So we are also working with some certain process like pulse laser welding or continuous wave laser welding to ensure that we get a good weld and we get a very precise joint. So we are working with a few internal and external sources. The Columbus Tech Center or the CTC they have a vast experience in laser welding. So is the CES, the Cummins Emission Solutions. So these are all the vendors and internal suppliers that customers that we are working with. Like I said in the beginning, we are also looking at use of green fuels, as part of our Destination Zero objectives. This is again driven by the global emission norms. What are the regulation policies that the countries are putting in place? Cummins as an organization also, ever since we took up the Destination Zero, want to reduce our material impact. So right now, this market is up and coming. So we can kind of get an early mover advantage. We have few applications which are approved for HVO fuel. Then HVO is nothing but a hydrotreated or hydrogenated vegetable oil, which is much greener. So we have some applications which are approved for ED95, which is the ethylene based diesel. We also, in the same way, we also have approved use of HVOs and some gas to liquid, like the CNGs and
Is
PNGs.
it a biofuel or something different than
H
biofuel?
HVOs are biofuels.
Hmm.
Yeah.
Okay.
Yeah, thanks. And we are also working with all these ASTMs and ISEH, the other industry consortiums, to understand what is the changing dynamic with when it comes to green fuels and how Cummins and Cummins fuel systems can be the forerunner to adapt these technologies and make sure we are offering the best value to our customers. Uh, this pretty much a long last slide in terms of competency. We are also, Cummins fuel systems. Like I said, we deal with a lot of high pressure applications. So 85 to 90, in fact, 90 to 95% of our parts are all metallic. So we have this emerging competency where we are looking into non-metallic materials. Maybe there could be some weight reduction or cost reduction options which will help our customers kind of get a total ownership cost goes down, because now you have an improved fuel efficiency because the weight is lower. You have a higher strength to toughness ratio, and there's a possibility of getting near net shaping. So we are removing a lot of processes in the upward stream supply chain. So we are trying to develop a kind of what I would say, encyclopedia or a guide which talks about compatibility across a wide variety of fuels, because not all elastomers of fuel are compatible with all the fuels, right? Some are compatible with diesels, and like I said, even our customers come back and say, "Hey, we want to use either a ED95 or an MD5. So is your fuel system?" It's mostly the elastomers where we say, "Oh no, that's not compatible. We need to go back and change it." And these seals are within the fuel systems. These are not just external where the customer can take them and remove them and put a new one. So we have to make those changes internally to the fuel systems. We are also working with certain thermoplastic and elastomer suppliers to develop advanced engineered materials specific for CFS applications. A couple of examples: we have reinforced PEEK now. We have a nylon tappet pin plug. We have a mixture of PEEK plus PTFE bushings that go on free of our applications. Again, these are driven, excuse me, these are driven through PPT projects, like I mentioned, because this is a product preceding technology. We are connected to all the required industries to make sure that we are aware of what are the up and coming changes and advancements that are happening here. And yeah, a few of the suppliers like Parker, where we partner with to develop any specific grades that Cummins Fuel Systems needs. So this is like a brief overview. Probably, I'm assuming it's different from what you had in the earlier sessions. I really didn't go into details of, hey, what material, and but I wanted to give a flavor that material science engineering is, evolving as a discipline where we are not just involved in, day-to-day laboratory inspection work, but we are also on the engineering front where we are. Uh, Shaking hands with business, marketing teams to understand, hey, what is the product, and what does our customer need? If some customer comes and says, hey, we need a fuel system which is compatible with so and so material, so and so fuel, do we have the right offering? What changes do we need to do to the existing product lineup so that we can meet the customer demand? That's kind of right at the start, infant stage, all the way to the end of the life cycle, where the remanufacturing or the recon, they say, okay, we have a customer now. Their engine is out of the warranty cycle. It's nearly near obsolescence, but they want to continue using it. So how can we remanufacture, without, adding too much cost to the customer? So we are kind of present end to end. These are the technologies or the competencies that we develop as a team within the group to ensure that uh, we are serving our customers, both internal and external, uh, to the maximum possible effectivity. So I thought I leave 20 minutes for questions, but yeah, I have about 12 minutes. If anyone has any questions.
Participants, you can unmute yourself and you can ask the question, or you can write in the chat box as well. By that time, Prashant sir,
Mhm.
whatever you discuss, I mean, you gave an outline that these are the requirements for the new materials. Can you name a few materials? I mean, which are advanced materials, and which, I mean, you are currently using in the fuel injection system, high pressure fuel injection systems?
Okay. Yeah, I mean, I'm not really at liberty to share some of the proprietary materials,
Yeah.
unfortunately. Uh, but for example, we have one high pressure application where, especially if you look at a fuel injection system, the most
Patil
stress.
sir. Please.
Yeah, the most stressed part is the injector nozzle. So we have an application from our one of our customers that, oh, we have to increase your nozzle exposure temperature to say 980 degrees Celsius, and the existing material will not work, right? So we worked with the steel mill in Europe. We tailored and developed a variation of a hot work tool steel, and we added a heat treatment process in it, which increases the oxidation resistance of that material, of that part rather. Um, and kind of that is in an application that's running successfully now.
Okay, anyway. Getme sir, you want to ask some question? Abhijit Getme? Abhijit Getme. Participants, you can unmute yourself if you want to ask a question.
Sir, may I?
Yeah, please.
Yeah.
First, thank you very much, Prasanth Sarji. Actually, really, session was very nice. Little bit it was heavy for us because we don't have
Yeah,
an expert.
actually, you are from chemistry background, right, Pratibha ma'am?
No, I am from physics background, sir.
Physics
But
background.
still, somewhat concepts and that particular devices or techniques, sir, discussed. Na? Meanwhile, the PCVD, TEM, and all these things, AFM. Little bit. I have that particular expertise with me, but there is one question regarding that particular MOUs or the summer trainings or any trainings for students. Would you like to available that particular things for the students, Saji? Means any academician or any college can approach to your organization in that particular regards?
Yeah, I mean, I think with respect to Cummins College, I think Cummins already has I mean, it's in the name. So we do have a long-standing relationship with the Cummins College. So yes, we should be capable. Of course, I'm not an expert on everything, but if you have topics that you would like someone from our industry to talk about, I can always find the right expert or the appropriate person who can talk about it. And thank you for pointing out. I realized that when Mr. Prasanth, Professor Prasanth said that, oh, no, there are people from other backgrounds. And then I was like, oh, no, I made a presentation which is heavily focused on materials engineering. And I was thinking it's not that focused on materials engineering because I really didn't talk about metallographies, metallurgies, what coatings, what is the microstructure looking like. I actually gave a very generic overview of how my team operates, what are the different strengths we have, how are we developing it, and how we are collaborating with industry experts, both academia and consortiums. But yeah, thank you for the feedback.
Thank you, Saji. But means science students or graduate students, you can allow in that particular. Means I'm asking about the graduate students because we have that particular stream with us. We are not the tech or engineering students with us. So even if the
Yeah, I
same.
mean, if you can send me the list of topics that could be of interest, I can always check within. And like I said, I can get you in touch with the right person who can provide that.
Thank you, Saji.
Ma'am, Cummins is working on hydrogen fuel, so
Obviously, Saji, but still, means actually, you know about all these things because we
yeah,
don't
the
have
I mean, see, the physics of the behavior of hydrogen fuel when it burns, that will help the Cummins to develop better hydrogen compatible components.
Sure,
Yeah.
sir, sure.
Yeah, I mean, I'll probably talk from experience from Cummins fuel systems side, right? But definitely, if we would talk to someone from the core engine business, they have their own set of problems, and that's what I said. If you can give a, a list of topics that could be of interest or where you can support or you need support, we can definitely find someone who will be there.
It will be our pleasure, Sajid. Definitely, we will approach in that particular regard to you and your comments.
Thank you.
Okay. Any other questions? I can understand. Huh?
I understand it's like everyone must be hungry by now. It's probably yes.
But yeah, that's the thing. But uh, especially mechanical people, and those are working on automobile, right? Engine related things. I mean, मतलब उनके लिए भी ये थोड़ा सा हेवी हो गया है, ऐसा लगता
Yes.
है.
But if there's any clarification questions and at the end of the day, I work in I mean, I myself am a metallurgical engineer, but I work in a mechanical system. But if you have any mechanical question, I'll try and answer it or answer it to the best of my knowledge, or take it to my team who can get it. I think you have my contact information, right, Professor Prasanth? You can just
Yes, yes,
yeah,
yes.
if anyone has any questions later that they can come up with, uh, please feel free to send me a note. And
Okay, okay, sir, no problem.
okay.
Okay, so better to conclude, right?
Yeah, I think we can close the call now. I want to thank everyone, and I want to thank I don't know if Professor Yogesh is still around for actually inviting me and having me here. And thank you for hosting this session, Professor Prasanna.
Thank you, sir. And
Yeah.
from Cummins College as well, I thank you. I mean, you worked and you are giving this session. I mean, you're delivering the session itself. I mean, so I can, I mean, only thank. That's what I can speak now, right? So,
Yes.
on behalf of college, I thank you all the participants for patience listening. We have a next session as well. So in 3 to 4 minutes, we will be starting the next session. So I request participants to be there. And Prasanth sir, you can and leave the call, right?
Okay. Thank you. Thank you, everyone. Have a good rest of your evening.
Thank you, sir.